Hello class, sorry I'm not there today. We are going to be starting chapter 8. So you should have a brand new packet. You should have the packet open to page 1. We're going to do the 8.1 notes, and then after the notes you should work on worksheet 8.1, which is the next page in the packet after the notes. You'll work on that, and then you'll rip it out of your packet and turn it into the sub before you leave. A lot of this stuff is review, so I don't think it'll be anything super difficult. Also for your projects, if you have your project, turn it in. If you forgot, you lucked out because I'm not there. So finish it up this weekend and then give it to me on Monday. Alright, so let's start 8.1. Remember that a polygon, we talked about polygons way back. A polygon is a closed figure made of straight lines. So just kind of fill this in as I go through it. Straight lines that do not cross each other. We name polygons by the number of sides. We can classify a polygon as convex or concave. A convex and a concave, if you remember when we did this before, concave has the word cave in it, which means that the sides kind of cave in. And then convex doesn't have the word cave, so the sides don't cave in. And I'll show you an example. I'll draw one in. Sides don't cave in. So concave would be something like this shape here, where it caves inward. That's a concave shape. Convex doesn't cave in, so something like this where nothing's caving in, that's convex. So that's the difference between convex and concave. Let's see, we also have these words which we've learned before, equilateral and equiangular. An equilateral polygon has all equal sides, and then equiangular has all equal angles. You'll notice that equiangular kind of has the word angle in there. So equiangular, all the angles are equal. If a polygon is equilateral and equiangular, then it is called regular. So let me draw you examples of what I mean. Equilateral is if all the sides are equal. So you can have, maybe a hexagon and pretend that all of those sides are exactly the same length. So you'd have markings on it that look like this, where all of the sides have the tick marks to show that they're equal. Or you might see a shape, this would be equilateral, maybe where all the sides are 6, something like that. Equiangular is where all the angles are going to be equal. So you might see, a shape like this where all the angles maybe are all right angles. Or in a triangle you might just have all little arches to show that their angles are all equal. Regular is going to have both. It's going to have equal sides and equal angles. So with triangles we did this already. You have all 3 sides and all 3 angles marked congruent. Or maybe you have a hexagon, and you'll have all of the sides marked congruent, and then all of the angles will have arches in them as well. So those are examples of regular polygons. We've got all the sides and all the angles equal. So what we're going to do in these next few problems is just decide whether these are concave or convex, and then whether they're regular or not. And again, regular means all the sides and all the angles are marked congruent. So like for number 1, if you notice, these sides here are caving inward, so this is going to be concave. And we have all the sides equal, but there are no markings in the angles, so it's not regular. It'd be equilateral, but not regular. So you'd say not regular, it's only equilateral. It's only equilateral. The next guy, none of the sides are caving in, so this one's going to be convex. And if you notice, all of the angles have arches or marks to show that they're congruent, and all of the sides have tick marks. So this one is regular. All right. Regular because all angles and sides are congruent. They're all equal to each other. Number 3, same kind of shape as number 2. It doesn't cave in, so that's convex. Notice that all the angles are equal, but there aren't any markings on the sides. The sides look like they're all the same, but we don't know that. So this one is not regular. It is only equiangular. Only the angles are equal. So it's only equiangular. Number 4, these sides cave in all 4 corners. So this one is going to be concave, but there's nothing congruent. Sides, angles, nothing. So this one is not regular. And just say something like nothing is congruent or something like that. Nothing is congruent. So those are some of the problems you'll see on your assignment in a little bit. The other thing you're going to see on your assignment is perimeter. It tells you in the directions that these guys are equilateral. Equilateral again means that all the sides are equal. So in the number 1, if this side's 8, all of the sides are going to be 8. And if you count it up, you have a total of 1, 2, 3, 4, 5, 6 eights. You just do 8 times 6, you get 48 feet for the perimeter. For number 2, same kind of thing. If this side's 7.5, and since it's equilateral, we know all the sides are the same, so they're all going to be 7.5 each. So you're just going to do 7.5 times 5. You're going to get 37.5 inches for your answer. And you'll just use a calculator, it's not too bad. Number 3, this is 11. All of the other sides are 11 as well. So you'll have a total of 4 of them. 11 times 4, you have 44 miles. Okay, and then number 4 would be the same way. All of these sides are going to be 3 feet. There's 1, 2, 3, 4, 5, 6 of them. So 3 times 6, you get 18 feet. So that's how you'll do the perimeter. Add up all the sides or just multiply it by how many sides there are. Then there's these problems. It tells you that these angles or these polygons are equiangular. And we're going to find the value of x. For this first one, I'm changing it to 7x plus 13 instead of 7x plus 3. Otherwise, it doesn't come out very nice. Since it's equiangular, we know that the angles are all equal. So if this one is 90, we know that all of them are 90 because they all have to be the same. So we know that this angle, 7x plus 13, has to equal 90. So 7x plus 13 equals 90, and then you just solve for x. So you subtract 13, you get 7x equals 77, and then divide by 7, you get 11 for your answer. Same thing with number 6. If this angle is 135, we know that all of the angles are 135. So we know that 5x plus 25 has to equal 135. You subtract 25 from both sides. You're going to get 110 here, and then divide by 5. You'll get 22 for your answer. And that's how those work out. Then these last 2 guys that we're going to look at, I'm changing the directions just slightly to make it a little more similar to the worksheet you're going to work on. We're going to find x, and then we're going to find the perimeter. And I added this side, the 2x, and this side for number 8, x plus 1. So you can kind of add that in, pretend that was part of the original problem. So what happens is it's still equiangular. So we know that this angle and this angle are the same. 2x is not an angle. This is a side. So don't set the side equal to 108 because that's an angle. So we know these angles are equal. It's just like the previous 2 problems. So 4x equals 108. And then we can divide by 4 to figure out what x is. When you divide by 4, you're going to get 224. No, I lied. 27. You're going to get x equals 27. So there's that. Now we have to find the perimeter. To find the perimeter, we're going to plug in 27 into this side so we can figure out what this one side is. So we have 2 times 27. We're going to get 54 for this side. If this side's 54, we know that all the other sides are also 54. So we have a total of 5 sides that equal 54. So to find the perimeter is going to be 54 times 5. And we'll get 270 for the perimeter. Okay, we'll do number 8 and see how that goes. You have the angles are equal. This is a side, so don't ever set a side equal to an angle measurement. Keep those separate. We know these angles are equal, so we can set 8x minus 4 equal to 60. Add 4, you get 8x equals 64. Divide by 8, divide by 8. You're going to get x equals 8. Once you find out what x is, now you can plug it into the side and find the perimeter. So my side is going to be 8 plus 1, or 9. If this side is 9, we know this side is 9, and we know this side is 9. So now we can find the perimeter. Perimeter is 9 times 3, or 27 will be my perimeter. So hopefully this helps. Again, sorry I'm not there. My son got sick. So good luck with everything. And again, work on worksheet 8.1, which is the next worksheet in your packet. Finish it up and then turn it into the sub. Just rip it out of the packet and turn it in before you leave. Have a good weekend. Thanks.